Okay, here are the notes for, well, the first part of the notes for section 2.1. Systems of equations. This is systems of two equations. They'll have two unknowns. And all they are, and you can see this first bullet right here, they're just two linear equations. That's all there are. So you'll have an equation with x's and y's in them. And a solution to a system, again, is two equations. So a solution is going to look like an ordered pair x, y that satisfies both equations, right? It's got to be a particular x and a particular y, that when you plug them into both equations, it'll satisfy both of them. And we will learn three different methods to solve. So let's start with the first method. It's called, it's by graphing. This could possibly be a little inaccurate, you know, if you don't draw your graph correctly, or if the solution doesn't fall on a nice grid mark on an integer, two integers. So let's check this out. All you do is graph both lines on the same graph, and your solution is where the two lines cross, right? It's where they intersect. That's going to be the particular ordered pair that they have in common. Alright, here's the first example. Let's solve this by graphing. We have these two equations. What we're going to do is graph them, and I'm going to draw a Cartesian coordinate system over here. But I am going to graph using the slope and the y-intercept. So let's solve this for y. I want to put it in slope-intercept form. Alright, let's move the 2x to the other side. The negative 1 over there. It was positive on the left, so it'll be negative on the right. Alright, and then we just need to change signs. Let's change all these signs. 2x plus 1. Alright? Now let's go ahead and graph that one. This will be equation 1. Nice. And you guys will be doing this graphing in WebAssign. Just going to make a little Cartesian coordinate system over here so I can graph these two. See how it comes out. Alright, so my slope is 2. Crosses the y-axis at 1. So you always start with the y-intercept, count over with your slope, positive 2. You go up 2 to the right 1. Or you can go down 2 and left 1. Either way, it's positive 2 slope. Yikes, that's supposed to be, oh gosh. That's supposed to be a straight line. Oh, that looks horrible. Anyway, yeah, it's supposed to go straight through there. Yikes. Let's count some more. Down 2 and left 1. I want to put kind of a bunch of dots on here because we want to see where it's going to cross that other line. Alright, let's try this other one. Here's the second one. This equation 2. That's horrible. Alright, solving for y. That was a 2x there. Let's put it on the other side. Alright. This time, my y-intercept is a negative 3. And I have a negative 2 slope this time. So this means I would go down 2 and right 1. Or I could go up 2 and left 1. There's the point they have in common. Up 2 and left 1. Alright, we found that. This is the second one. Man, those are supposed to be straight lines. Yuck. Not very good. Alright, where they cross, they do indeed cross at a good grid mark. That's going to be our solution, which is, what's that ordered pair? Negative 1, negative 1. Just like that. Let me highlight this because that's the answer. Yeah, this one, the graph was a little wonky, but that's how you do it. All you have to do is graph both of the lines, and the ones that you have in your homework shouldn't be too many of them. It should be fairly straightforward that you can graph them pretty easily, and they should land on a good grid mark. Alright, that's method 1. That's just by graphing. So you have to be okay with graphing a line. You do that at the end, tail end of Math 101. Why did I leave so much space for that? Oops, okay. Yeah, let's get to method 2. Method 2 is called the substitution method. And these two bullets under here is sort of what we're going to do with the substitution method. You take one of the equations and solve for one of the variables. right? So you can either solve the first equation for x or the second equation for x. Or you can solve the first equation for y or the second equation for y. It doesn't matter which equation, doesn't matter which variable. And once you do that, you substitute into the other equation. Alright, then you solve that resulting equation. In that sense, you're going to have one equation and one variable that we know how to solve. Now, the easiest thing to do when you have a system you're supposed to solve by substitution, what you want to do is look for a coefficient of 1, because that's going to be the easiest thing to solve for, the easiest variable to solve for, because you don't have to deal with fractions. So I'm going to choose equation 1, and I want to solve this for x. So the x by itself, let's just add the 2y, put it on the other side with the negative 16. See, that was a negative 2y on the left. If we add it, it'll be on the right. Alright, so that was pretty easy. We have x equals 2y minus 16. So what I'm going to do is take all of this. We just solved one equation for one variable. Now we're going to substitute it into the other equation. Where I see x here, I'm going to take this and stick it right there. Alright, I'm going to take all of this and put it right there where that x is. Okay, the blue x down below. Alright, so if I do that, it looks like this. Rewriting that second equation is 3. Remember, my x equals 2y minus 16, and let's finish the rest of this. Minus 4y equals negative 34. Now, I've got this one equation, and there are only y's in there, one variable. I no longer have two equations with two unknowns. I've got one equation with one variable. Know how to solve that. Let's go ahead and solve it. We'll distribute alright, just like that. Then let's combine some like terms over here. 2y minus 48 is a negative 34. So I've got my variables over here. Let's move that constant to the other side. If I add 48, well, I have a 14 over here, positive. Good. Then when you divide, y equals 7. Alright, I have the y coordinate of my answer. Remember, your answer's an ordered pair. I've got the y part, y equals 7. Now to get x, you can find out what x is right here. Or again, you can plug it into one of the original equations. It doesn't matter. Let's see what x is going to be. X equals 2 times 7 minus 16. 14 minus 16 is a negative 2. So you're going to want to write your answers as ordered pairs. This is x over here. Yeah, write your answers as ordered pairs. Now on your test, I'm not going to care if you keep it separate, but you need to give me both answers. Alright, when you solve for y, make sure you give me the corresponding x that goes with it. And make sure that you show all of this work, because your calculators can solve systems of equations. So that's why you have to show the work, and you have to use the method that the problem says. So it's either by graphing or by substitution. Then we're going to learn one more method. You know, and you can check these two. You can check the negative 2 and the 7. It's got to satisfy both of those equations at the same time. You know you got the right answer. That'll be really important on a test. You can tell if you got the right answer or not. Alright. I just left way too much room, but that's okay. Alright, step 3 is down at the bottom of this page, and an example on the next page. Method 3 is the elimination method. Alright, what you're actually going to do is eliminate one of your variables to solve for the other one. Because you know, we only want one equation with one unknown that we can solve. So we're starting off with two equations and two unknowns. So the elimination method, what you do is you try to match coefficients but be opposites. And I should have put another bullet down here. Then you're going to want to add the equations together. to eliminate that variable. Alright, I'll show you what I mean. The elimination method, I prefer this one, but substitution works well with some systems, so if it doesn't specify, you can use any method you want, but I'm almost positive on the next test, I specifically tell you to use substitution method for this problem, use elimination method for this problem, if I'm not mistaken. Alright, so here's the example on the top of page 3. Watching the time. I should be able to make it through this example, and then I'll have to do another video. Alright, solve by elimination. So the elimination method says what I'm going to do is eliminate one of these variables. It doesn't matter which one, but we're going to pick one of them that we're going to eliminate. And the way that you choose it doesn't matter if you want to eliminate the x's or you want to eliminate the y's. Let's say I want to eliminate these x's here. So what I need to do is multiply this whole equation by something so these coefficients match, but they're opposites. I've got a positive 7 here and a negative 14 here. So if I take this whole equation and multiply by 2, I will get 14x minus 4y is equal to 28. Alright, and let's bring over that second one. Didn't do anything to that second equation. Alright, so all I've done, look at those x's. The first one is a 14x, that's an arrow. Let me get rid of that arrow. Okay. The first one is a positive 14x, the second one is a negative 14x. If I add straight down, those are going to cancel themselves out. Alright, then over here, I've got negative 4y plus 6y is going to give me a 2y. If I add these, that gives me a 10. Then I can easily solve for y. That's supposed to be 5. Alright, y equals 5. I've got the y part of my answer. Now to get x, remember it doesn't matter which one you want to plug it in, makes no difference. Let's go ahead and plug it in the first one, doesn't matter. This one's actually going to give me a fraction for x, and that's okay. That happens. Y is 5 equal to 14. Alright, so 7x minus 10 is 14. Let's go ahead and add 10 to both sides. So then x is going to be a 24 over 7. And you can leave it just like that. They won't always come out to be nice integers. It's no big deal. Try not to write a mixed number like 3 and 3/7. I'd rather you leave it as an improper fraction, reduced down as far as it'll go. Alright, so this is already reduced all the way. I'd rather you leave it like that. So the answer to this is x. The x value is 24 over 7. You can leave them separate if you want. The best thing, though, to do is to write them as an ordered pair. Make sure your x comes first and the y there was 5. X and the y. Okay, before we start this next part of the notes, I'll do that in the next video.